Okay, thank you. Good afternoon to everybody. Thank you for the opportunity to make you aware about what we are doing here in post-communist countries. I'm not new in the community. I'm a standard guy, representative in urban ITS standardization, and I also spent 6 years in traffic research. So I am now running a small consultancy to really come up with such a innovative projects that I'm going to share with you today. Well, I try to put it not to, yeah, right. The today presentation is about the case which is in Žilina in Slovakia. Žilina is a 70,000 inhabitants city. It's a regional hub, and we have deployed an innovative IoT sensors network to make a geofencing for the parking policy, but also for some city development, digital planning, etc. We are based on the company CITIQ, which is an innovative small company founded in 2012. The biggest issue to mention is the 2017, when the Skoda Auto has paid for the biggest IoT mobility system here in the Czech Republic. There are more than 250 devices today, and it produces 350,000 traffic messages per day. So it's a robust system that really is focused on parking occupancy, so for the Skoda Auto employees, but also traffic burden to the adjacent villages that the Skoda Auto potentially does. I should also mention 2018, where the traffic classifier, which is also a unique device in this world. As I scanned the market, there is none of such a thing in the world, and the competitors have always 2 or more devices to do the same job. In 2020, there was a first factory lab, so we have really settled up a kind of a LoRa network to show some use cases that are not just traffic oriented, that I will show you. And I'm going to speak today about the first urban lab, which is in this Žilina. Just to summarize, there are about more than 50 systems in 30 cities today, in 9 different countries. The main use cases are really regional or national digital traffic counting, road maintenance and planning, parking occupancy in different ways, traffic safety monitoring as a kind of a statistics input, a new thing which is a first predictor, a special device that measures ice on the sidewalks, microclimate monitoring, so to combine traffic issues with climate change issues. And all this heads up to digital urban plan, so something like the city rules for developers, how to build more sustainable smart quarters, smart districts that really support sustainable mobility. This is how it looks like. This is a traffic classifier. It can run on different communication networks, as you see, LoRa, Sigfox, or IQRF with this mesh network. It can count the vehicles. It measures their length in 3 categories, and you can set up the initial velocity. So, for example, for Skoda Auto, it was 40 kilometers per hour within the plant. And it can also measure speed up to 5 categories. This is not available for Sigfox, as there is some kind of data limitation, but for LoRa or other networks, you can really profit from such a solution. And the most innovative solution actually right now done is that we can also measure the pavement temperature. So you can really use it twice. This is simplification of how it is installed and how you need it. So you need one classifier per lane. The installation takes about 20 minutes. It's a standalone device, battery powered. We have experienced that it can really give us some data every 10 minutes or even every 5 minutes. And it can work for 3 years based on the battery. You need 10 more minutes to make it replaced. What are the major advantages is that there is no construction permission needed, no GDPR issues. So if you decide today to deploy it within 2 months, you can have your system. So this is a kind of a dashboard to really showcase what data we have from such a device. Every device can give us such data. This is a traffic safety department from Skoda. You see that this is the last November screenshot, 15,000 vehicles per week in different days. Blue color is for cars, red color for vans, and green color for trucks. Approximately it's up to 7 meters, 7 to 14 meters, and more than 40 meters. And we also provide some top speed. So it's very for traffic safety. It's focusing on such an item. And we have also been able to deliver a kind of a table of overspeeding. So really to map a whole plant and to see there is a problem. This problem is much more focused than the other side. For the Žilina use cases is real because we have run a project, an Interreg project called SOLEZ. And within that project, we have deployed the kind of a first deployment of such a thing. 20 sensors based on Sigfox in 2019. And we really tackled with traffic issues, mainly parking policy. And now we have kind of a second roll-up. I will explain it later that we have spread the solution to much wider geofencing thing. And all this is really adding to some kind of a digital urban planning. This is an illustration of the output. So it's also a proof of the accuracy of the measurement. You see that we have done it in 2019, and this is 1 day from midday to midday. So about 4,000 vehicles per day to go in and 4,000 out, and the difference is about 100. So the accuracy is really 97 plus. We have cases that the accuracy is less. It really depends on on the placement of the sensor, but we also have cases where we have 99 plus. So it's really depending on how the vehicles are moving. The key questions when dealing with public administrations were like, do we have enough parking spots? So how we can really measure the demand, or which entrance is the most used, and where the traffic safety can be really focused on. And also what happens when we do something with the parking price. But nothing of that happened. The main output of the project was that the public administration is really hard to really treat the data and to work with them continuously day by day. So this data-driven decision making is quite new and quite unused. That is why We have come up with a new project, which is also an Interreg, but Czech and Slovak cooperation, cross-regional cooperation. It has two main issues to tackle. One is the urban lab I'm going to present you today, and the other is IoT use cases catalog, just to show what public sector could buy, why, and what is the best level of public sector that should buy such a thing, and to provide the services to the others. As you see, there are partners like Transport Research Center from the Czech Republic, but also the University of Žilina, my consultancy company CITIQ, and the manufacturer and producer company CITIQ. So it's like this. This is the map. I have designed it quite in a simple way in Google Maps. The black cars are the former project, so it was focused on really a close area in 2019, and in 2021, a week ago, we have deployed this violet geofencing, and we have covered all the entrances and exits to the center. So we can really come up with some numbers about how many cars go in the town per day. And we also combine it with some microclimate measurement and also some pavement temperature measurement. So there are some more use cases to show. It works like that any installation crew can just scan the QR code within a mobile app and make a registration of the device really per place. So you have the time of installation, you have also the true number of the device and true location. So it's kind of a key thing when you think about the sensors network. This is the backend, we can say. So we have kind of an IoT registry when we see how many devices and where they are put. And on the right side, you really see, it's in Czech, I'm sorry for that, but it's how many types of devices and how many pieces of such devices we have for such an implementation. So this snow symbol is about really pavement measurement. It's a special sensor I will show you later. Then the blue light, it's a traffic classifier with temperature measurement. We have two of them. We have 21 traffic classifiers based on LoRa, Sigfox, but also with IQRF communication to do some downlinks. And we have also a simple traffic counter. So just to really show what we need. And there are 6 of them. This is how, I'm sorry.
We have to look to the time.
Yeah. 2 more minutes.
Okay.
This is a climate change use case. Here at the picture, you can see the sensor that is able to measure temperature of the pavement in 3 depths. So you can really prevent black ice or something like that. That's one particular use case we are implementing here. It's complemented with meteo stations and some also road pavement sensors. We are going to publish the data as open, and we would love to make it also as a kind of standard. That's why we are cooperating with Jan Brzezinski that to really come up with the DATEX II profile or extension. I don't know what it will be, and we will publish it in the autumn. So as a kind of a new standard for cities to really start to work with such data. The data is really something extraordinary here. And here you have kind of a parser, how it looks like for Sigfox. So it just should give you some insight into what data and how the data looks like. And And the last thing, this is our promo, just to really promote that manual counting is a history, and we should really focus on something which is cheap, which you can really deploy fast, and you can collect standard data from all the system for any purposes you can imagine.